I'm here to educate you all today about a certain topic in natural history, namely the synapsids of the Permian era. Unknown to most people, there are actually other parts of time that do not involve dinosaurs, that do not have dinosaurs in them. These are little known parts of time that often get overlooked due to the insistence of popular culture. I'm here posting this video to, correct this somewhat. It happens, it just sort of happens. Television, you always see T-Rex or Velociraptor, the two big dinosaurs, but there are many parts of history that people know little to nothing about. And I believe that Permian era synapsids are a group of animals that are every bit as interesting and somewhat important. For those of you who don't know, synapsids are actually the precursors to mammals. They are to us what dinosaurs are to birds, in fact, and they have many different evolutionary stages. I've seen other videos on YouTube that are very good at explaining things like this. I know Dinosaur George is one of the frequent videos that pop up when you type in things like this, and heck, I've watched them, they're pretty dang good. So I'm trying to I suppose do something similar, but something that people know little to nothing about. Of course, I'm generalizing there. Some of you may be very very well educated in that particular area. Now, as far as synapsids and their precursors, there are many different types of synapsids. The one that most commonly comes to mind is Dimetrodon. That's probably the best known and is often mistaken for a dinosaur for a lot of good reasons. It's often portrayed as a reptile, and in effect it is. Synapsids and therapsids especially are basically a mix between the two. I hate it when we talk about evolution and many people always bring up missing links. This is a missing link, that's a missing link. That's not how it is. There are, I want to say, phases to each family as you go down or up the tree. Amphibians would be a good example. They're sort of the cross between fish and reptiles. They're that in-between point. And if you look at it more and more, there are more in-between points, or intermediations, I suppose. Stegocephalians are closer, the mix between amphibians and reptiles. Sarcopterygians have many intermediates between fish and amphibians, excuse me. It just sort of happens, and I think therapsids are one of those examples where you have a cross between reptiles and mammals, and they have a lot of the same features, and as time goes on, they mix in DNA. But the closer you get to the Cenozoic, I mean, therapsids particularly, and synapsids, started out in the Carboniferous era, and went on right into the Triassic, where I'm pretty sure it was either the Triassic or Jurassic where they've actually become mammals at that particular point. So my point being that they're an intermediate, a little bit of both. As you leave the Triassic, they become more and more mammalian. In the Permian, they still have a lot of reptilian features, and they are considered amniotes, so I'm guessing that at least in the Permian and possibly even in the early Triassic, they probably laid eggs. They did manage to survive the Great Dying, the Permian mass extinction, and That's another big part of it. Without the Permian mass extinction, I think the world would be a very different place. I know dinosaurs would never have existed. Archosaurs would never have been given the chance to take the ecological niches left open by the extinction. As far as the way Synapsids, interacted, I'm not entirely sure about interaction between Synapsids. A lot of my information that I've been getting is from this particular book here, Forerunners of Mammals. I'm not exactly sure how to pronounce the author's name, so I'm just going to run it by you. Sorry about the camera. The camera's not the best in the world, but yeah, whatever. Another good book on the subject, and a book that will actually sort of fill you in on many other Paleozoic species and the other animals that have lived throughout time, would be Life Before Dinosaurs. It's a very good book. It just came out. I do believe the author's name is Sebastian Steyer. And for those of you who find technical reading very boring, there are many colorful pictures. That's also a very good, it's a very good source of information. As far as synapsids go, they were dominant, especially in the Permian. I've said this, and at that particular point, the world was much warmer, significantly warmer, and the supercontinent. They lived on the supercontinent of Pangaea, which many of you have probably heard associated with dinosaurs, but this particular continent's been around a very long time. Was anyway. When it comes to all of that, I know that northern Pangaea was very volcanic, especially in the Permian, probably mid to late Permian, and that's one of the factors attributed to the mass extinction. And being that the continent itself is so huge, I'm guessing it takes up probably 2 to 3 oceanic gyres, and that, when you mess with the gyre, which is a revolving current in the Earth's oceans, there are 5 of them presently in today's oceans, and I'm guessing there were 5 in the Permian. If you were to get into the way of one of these gyres, continental drift interrupting one of these gyres, I'm guessing that things would be, I would say, chaotic as far as climate is concerned, which may or may not have been one of the factors contributing to the extinction. I know Siberian traps were one of the things to blame, and everyone throws asteroids. They always say asteroids, whenever an extinction event's brought up, because they have no other way of explaining it. There are other things other than asteroids. Every time a species dies out, a giant rock doesn't plow into Earth and kill everything. I would like to think that the continent, being as big as it is part of the problem, interrupting gyres. The volcanism in northern Pangaea would be the equivalent of the greenhouse gases, and if you look at it, there are a lot of parallels between what happened in the Permian mass extinction and what's actually going on in today's world. Again, you'll have to do some looking, but you'll see what I'm talking about if you do. Which is why, if you look at any news source that loves to terrorize people and post frightening news articles or something on television, they'll always say, oh, there's a large extinction coming up the pipe. When they say up the pipe, I'm not exactly sure how far or close they mean. I would assume somewhere to the tune of 100,000 years. That's just because that's how long it took for the Permian mass extinction to wipe everything out. And unfortunately, it took about 30 million years to recover from all of that. So, right after that extinction, you could probably walk around and there would be nothing bigger than a small prairie dog running around. As far as the oceans go, you could probably go swimming wherever the heck you wanted and not worry about being attacked by sharks. That's essentially empty. Wiped out 90% of all oceanic species and 70% of all terrestrial species. As far as the oceans go, I think the ecosystems in the hydrothermal vents in the deep ocean were probably the only ones untouched. As far as land goes, I know they've attributed a lot of that extinction to the dropping of the water table all across the board, all across Pangea. And with the water table dropped, grasses and other things aren't allowed to grow, thereby starving the herbivores, in turn starving the predators. So that's part of the ecosystem collapse, the dangers associated with volcanism. I believe in the late Permian, desert temperatures in central Pangea were, I'd heard 118 degrees, I'm not entirely sure. And like I said before, if any of you know something or you see a hole in something I've mentioned here, please post it. I'd love to hear it. I don't know everything. And yeah, that's another goal of this video, is to figure out some things and perhaps learn some things I don't know. Your responses would be more than welcome. I'd love to hear from everyone. And yeah, that's about all I've got to say. Thanks for watching.